Hello, today we're going to paint a scenario with in programming with data structures. Okay, we're going to pick out the best data structure to work with in a particular scenario. So just read this real quick and then we'll get to the answering. You have been asked to help write a computer game that simulates planting and growing a garden. In this game, the player moves throughout the landscape trying to discover piles of seeds which can be planted back in the garden space. There are different kinds of seeds, for example, pumpkin, tomatoes, peas, etc. And in each pile of seeds, there can be many different amounts, for example, 5, 25s, or 100s, etc. When the player picks up a pile of seeds, it gets added to their supply basket. After placing seeds in the supply basket, the player can then plant them. When planting seeds from the supply basket, they can only plant the ones they most recently picked up until the seeds are all used. So for example, if they pick up a pile of pumpkin seeds, later a pile of tomato seeds, they would have to plant all of the tomato seeds before they are able to plant the pumpkin seeds. The player cannot plant seeds if the supply basket is empty. Once seeds have been planted, the player can water and fertilize them in any order they would like. As long as they have sufficient water and fertilizer, plants will continue to grow until they are ready to harvest. At that point, the fruit can be harvested or the plant can be left alone, in which case it will eventually turn into new pile of seeds that can be picked up. Now, what would be the best data structure to model behavior of supply basket? Well, personally, I would pick up a stake, because a stake is a last in, first out process, where the example that we got here that says that we have pumpkins, right? You pick up pumpkin seeds and then you pick up tomato seeds after. You have to plant the tomato seeds, and then after the tomato seeds, then you can plant the pumpkin seeds. So stakes just take the last item in, out, and you cannot pick anything at the center. And then what is the time complexity of any to supply? Well, this is big O, that's N0. And then what is the time complexity of removing from the supply basket? It's still N0 as well. What is the time complexity of checking to see if the supply basket is empty? It's still N0. Well, thank you so much.